Now we're going to explore the idea of confidence interval that estimates the difference between population proportions P1 and P2. In order to construct a confidence interval estimating the difference between population proportions, the confidence interval estimate of the difference between two population proportions is denoted by, you have P1 minus P2, which is bounded between the difference between sample proportions minus the margin of error, and on the other side, you have the difference between sample proportions plus the margin of error. In that case, to calculate the margin of error, or E, we're going to follow the formula of E equals to, we're going to find the critical value, Z, and then multiply that by the square root of P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat divided by N2. Let's take a look at a few examples. We want to know if there is a difference between success rates of e-cigarettes and nicotine replacement for smokers who try to stop smoking. In the table below, we have two sample proportions of success for the e-cigarette treatment group and the nicotine replacement treatment group. First of all, our table, which is the results of smoking cessation trials, you have not smoking after 52 weeks, number of subjects. For the e-cigarettes, you have 79 out of 438. And for the nicotine replacement, you have 44 non-smoking after 52 weeks from 446 applicants. Now we can easily construct the P hat. P hat is the sample proportion. The sample proportion for the first group is 79 success out of 438, which is about 18%. And for the nicotine replacement group, the success is 44 out of 446, which is about 10%. With a 95% confidence level, as you remember, the critical value is 1.96. So for those of you who forgot about the critical value, if you have a 95% level of confidence, the critical value is 1.96. We can use this information to find the margin of error. The margin of error, which is the critical value times square root of P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat over N2, can be calculated as 1.96 times the square root of P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat over N2. So all of this information about P1 hat and P2 hat are taken from our calculation in the very first step. This is equal to 0.0454152.1, or about 5%. So we basically calculated the margin of error. Now we can move on to the next page. The difference between population proportions is bounded between the difference between sample proportions minus the margin of error and the difference between sample proportions plus the margin of error. So the difference between population proportions is bounded between P1 hat minus P2 hat minus the margin of error. And remember that our margin of error that we calculated is basically just 5%. On the right-hand side, you have the difference between sample proportions plus the margin of error that we calculated up here. Now, the difference between population proportions is bounded between 4% and 13%. But what's the meaning of that? The confidence interval limits don't contain 0. It suggests that it is very unlikely that the difference between sample means is equal to 0. So there is a significant difference between the two proportions. So as long as the difference between proportions doesn't include 0, you're going to say that there is a significant difference between the proportions. Let us take a look at our calculator and use calculate84 to do the computation. Calculate84. Let me share the screen with you. So in order to construct the confidence interval for two population proportions, first you're going to click on Stat, and then you're going to go to Tests. In the test, we have two sample proportion, but it's not a test. This is an interval that we try to construct. We're going to construct two proportion Z interval. So our goal is to construct two proportion Z interval. Click on that and enter the values. So let me erase these. Here we have X1. I'm just borrowing from the information that I have entered here. X1 is the number of successes in the first sample, which is 79. N1 is the first sample size, which is 438. The second sample success is 44. And the total number of values in your second sample is 446. The level of confidence is 95%, so 0.95. Let us click on Calculate and enter. Very good. So as you can see, you can compare your manual calculation with the calculator calculations. On the left-hand side, we have 0.0363. Here we have 0.0363, which is very accurate. On the right-hand side, you have about 13%. And as you can see, you have about 13% on the right-hand side. So the calculations using a calculator and manual calculations match.